Welcome. So for all of the longer videos that exceed 30 minutes, and I know I try not to run over too much, although I do, this video will be a shorter one. Hopefully we'll come in under 15 minutes, I would think. If we don't, I apologize. But angles should be pretty quick. There are a couple key things you need to know, and we'll go over those things, and then we'll just look at kind of some of the harder problems. We'll do one of the easier ones, and then we'll look at some of the harder problems at the end of this packet. But when it comes to angles, and we'll get more into like shapes and triangles in the subsequent geometry packets, but just kind of when it comes to angles, a few basic things. Straight line is always 180 degrees. So if we're looking at this straight line right here, A plus B plus C have to add up to 180 degrees. So maybe, I'm just making this up, but maybe this is 50. This is, let's say, 60. So that means C would have to be 70. And I know that's probably not proportional, but anyway. A circle. So whenever you have a circle, all of it has to add up to 360 degrees. So a line is literally half a circle. So whereas a line is 180 degrees, right? 180 degrees for the line. Circle is two lines. So here's our second line right here, right? Second half of the circle. So that's 360 degrees. And the cool thing about this is you know that opposite angles are the same if you have a transversal or the lines intersect like this. And you also know that if you have opposites, if this is 62, well, because this is a straight line right here, this has to be 118. They have to add up to 180. Anyway, make sure you read through these tricks. There are a couple common things with, well, actually, let's kind of talk about parallel lines. So when you have parallel lines, as we know from earlier, transversals have to be the same. So these both have to be 74. The other thing you need to know is opposite interiors are the same. So whereas this is 106, this is going to have to be 106. And once you know that opposite interiors are the same, then you can use transversals to figure out the other ones. And if you have a straight line, so like if this is 106, then you know that that has to be 74 for this whole thing to add up to 180. And the specific rules are all here. Alternate interior angles are the same, corresponding angles are the same, corresponding meaning, and then consecutive interior angles add up to 180. So these are, if you think about it, 106 and 74 are consecutive interior angles. But anyway, it's with if you know that opposite interiors are the same and you know transversals, you can kind of figure out what you need to know on parallel lines. But the one thing I will say about the test is a lot of times they'll give you a parallel line situation like this, where they tell you have parallel lines, they do it with this symbol. But because you have intersecting lines, it creates a lot of noise. And we'll look at kind of how to navigate that in a little bit. Another big rule before we get into the problems is you need to know that a triangle is, as you probably already know, is 180 degrees. If you add up all the interior angles, right? Well, the minute you go to a four-sided figure, it doesn't have to be a rectangle or a square. I mean, a rectangle is pretty easy to think about because it's 90 plus 90 plus 90, but it could be any four-sided figure. It could be like this guy that I'm drawing, right? The interior angles of this guy and of the rectangle, they have to add up to 360. In fact, every time you add a side, you add 180 degrees. So if we're looking at a pentagon, that's 540 degrees. If we're looking at a hexagon, 720 degrees, and so on. In fact, the formula is right here. It's the number of sides minus 2 times 180. So if you had a triangle, 3 minus 2 is 1. 1 times 180 gets you the number of degrees of all the interior angles of a triangle. And if it says it's a regular figure, a regular polygon, that means, so like a regular hexagon. I'll do my best to draw this to scale. Apologize, I know it's far from perfect, but a regular hexagon means that all sides are the same and all interior angles are the same. So if you needed to figure out the interior angle of a hexagon, you just figure out the sum of all the angles. So 180 times 6 minus 2. So 4 times 180, we know we would have 720 on the top, right? Because we put in a 6 for n, the number of sides. And then you would just divide by 6. And that would get you the angle for each one of those sides. So in this case, 720 divided by 6, we might as well do some long division. So 1, 6, subtract that, bring down the 1 there, bring down this 2, and that goes in twice. So, and that gets us 12. Bring down the 0. So we're looking at 120 degrees for each side. Anyway, let's go right into the problems here. So I chose 3 not because it's difficult, but because it has a couple key concepts that tend to confuse people. So I just want to clarify those concepts. So it says Marissa's design for a rectangle stained glass window with 7 triangles is shown below. The 2 white triangles are congruent, and it gives us this symbol for congruent, this one. So it gives us the 2 lines and then kind of like a squiggly line above it for congruent, like that. And it says, and will be a different color than for the 5 triangles. The design includes the measures of these angles, so CAB. If it says CAB, it's really talking about angle A. Whatever angle's in the middle is what it's referring to. ACB, so ACB is talking really about angle C, and DCE is talking about angle C for this triangle. What is the measure of CED? So if it's asking for the measure of CED, CED, and I should draw that a little better, it's really asking for the measure of angle A. All right, so a couple of things I want to mention. Congruent is geometry speak for the same. That's different than similar triangles. Similar triangles can have the same angles and the same proportions, but one can be larger than another. So if this were like a 3, 4, 5 triangle, a similar triangle version of that would be if I just doubled everything in size and said, okay, now we have an 8, 6, 10. So similar triangles means proportions are the same and angles are the same, but congruent means they're literally the same triangle. So not proportions are the same, it means they actually have the same length for their sides. But anyway, when we're talking about these being congruent triangles, a key thing to look out for is it says ABC and DEC. So A corresponds with D, right? A, B, C, and DEC means that the first letter of this one corresponds with the first letter of this one. So if this is 70, this is 70. So 70, 40, we're looking at 115, and we have a triangle which is 180 degrees, so 180 minus 115. We're looking at angle E being 65 degrees. The other thing you can always do if you're stuck is you can use your eyes and logic. You don't have to, you don't have to abandon logic and just stick to pure numbers when you do this. If this is 45 degrees and we're looking at angle E, well, it's definitely bigger than 45 degrees. It's a bit more opened up, so we can get rid of that. 115 degrees and 135 degrees are both obtuse, meaning greater than 90 degrees. 90 degrees would look like this for angle A. So this is definitely less than 90 degrees. So really, just immediately, you have a 50% chance anyway, just by using logic. Okay, let's look at some of these harder problems. I promised harder problems, we'll do harder problems. If you want to try these harder problems on your own, then just pause the video and give them a shot before I show you. I'm gonna skip. No, let's do 13 real fast. 13 is kind of medium, and then we'll do the 2 ones at the end. Okay, so triangle ABC and collinear points ACD are shown in the figure below. The measure of A is 43 degrees. The measure of BCA is 4y, right? BCA, so C is our reference angle right there, is 4y. And the measure of BCD is 11y. What is the measure of B? Okay, so again, a straight line is 180 degrees. ACD right here is a straight line. So we know that 4y plus 11y, in other words, 15y, equals 180 degrees. Okay. Well, 15 times 10 is 150. So it's going to be 15 times 12 to get to 180. And you could do long division. You can do this any way you want. You'll have a calculator on this test. But anyway, we have that y equals 12. So if y equals 12, 4y, this interior angle here, is going to be 48. 48 and 43 together, right? Because we know that the three interior angles of a triangle have to add up to 180. So we have 180 is equal to 43 plus 4y, which is 48, plus b. Okay. Well, we add these together, we get 91. We take 91 away from 180, and we have that 89 equals b. Right, 91 are these two together, so 91 subtracted from 180 gets us 89. Okay, let's look at two more challenging problems. So this next problem goes over a concept that's really important to me. It goes over a couple important concepts. So if you remember at the beginning of the video, I said sometimes you'll get parallel lines, but you'll get a lot of action. This problem is the exact type of example I was thinking about when I mentioned that. So we'll read it. I'll show you how to do it by the book, and then I'll show you kind of a clever way to get around the confusion. But let's do it by the book first. So in the figure below, lines A and B are parallel. The angle measure of y in degrees and angles 1 and 2 are the same measure. Okay, so, and then it says in terms of y, which of the following is equivalent to angle 3 in degrees? So we want to know how to represent this angle in terms of y. There's a lot going on here. You can pause the video and try this one out. You can pause the video and reread the problem again, but I'm just going to kind of keep on moving. So here's a big thing I want to show you is, so we know 1 and 2 are the same, but the first thing I want to establish here, and I'm going to white out this line right now, and you'll see why I'm doing this in just a second. Okay. So now with this line gone, this becomes really obvious. We have two parallel lines and then a line that intersects them. So 1 plus 2 equals y, which means that 1 and 2 are y divided by 2. Because it says 1 and 2 are the same. And we know 1 and 2 are y because of opposite interior angles, right? This is going to be the same as this. Okay, so now that we know that, let me put this line back. And let me erase this other line. And again, you can redraw these figures. You can put your hand over the line. Obviously, you won't have the ability to white out a line on the test. I'm just kind of doing it for visual effect. But the minute you know that 1 is y divided by 2, that means that 3, because opposite interior angles here, right? 3 is also going to be y divided by 2. So that's our answer. Our answer is A. That problem comes at the way end of the test because it's really kind of, can be difficult to see exactly what I just did. So I'm going to give you another way around this problem. I'm going to give you a way that I actually think is easier. I talk about this often on the test. In the worksheet, I believe, is plug 216. If you want to take a look into that worksheet, it's a good way to kind of back solve a lot of problems. But whenever your answer choices are all expressions, and this is really kind of angle 3 equals for all of these. Anyway, for all of these, it's angle 3 equals, and so on. So what we can do is, because these are all expressions, we can just plug in a number for y, and just play the problem from there and see what happens. And sometimes it's just a lot easier to operate with tangible numbers. So looking at y, I don't know, let's call y 60 degrees. Okay, I'm just making up an angle to hold the place and to kind of help us think through this problem. So if this is 60 degrees, we know this to be 120 degrees. Okay, so if we're going to figure out angle 3, we just need to know what angle 2 is. Okay, well, hopefully what we realize is that if this is 60 degrees, this entire thing, angles 1 and 2, are going to be 60 degrees as well, right? Again, because of earlier, if we ignore this line right here, if this is 60 degrees opposite interiors, angles 1 and 2 add up to 60 degrees. 1 and 2 are the same, so that means that angle 2 is going to have to be 30 degrees. I'll do that in a different color. Student green. So angle 2 is 30 degrees. So if angle 2 is 30 degrees and this angle is 120 degrees, angle 3 is going to have to be 30 degrees, right? So we know that angle 3 is going to have to be 30 degrees. So we just now, knowing that we made y 60, we just need to see which of these answer choices, when we plug in 60 for y, gets us 30 degrees. A does. 60 divided by 2 equals 30. All these other ones are going to get us other numbers, right? You can just kind of run through these in your head and plug in 30 degrees, 60 degrees, sorry, for y, and realize you're not going to get out 30 degrees, which is what you need to get out, because it's saying which of these expressions represents 30 degrees, or angle 3. Anyway, that doesn't really make sense. Maybe dive into worksheet 215 if you want to learn more about that concept of just kind of plugging in numbers to think your way through problems where all the answers are expressions. But all we really did is we called y 60. We followed the rules to figure out numbers for everything else, and then we just made sure that our equation balanced. We knew that if y is 60, then 3 is 30. So the correct equation will balance when we have 60 in for y and expecting the 30 output for 3. All right, one more problem. This last one's a really cool problem as well. So if you want, pause the video, give it a shot. Otherwise, we'll just keep on running. So in the figure below, AB is parallel to DE. The measure of ABC is 49 degrees, and the measure of BCD is 137 degrees. What is the measure of CDE? So CDE is going to be CDE. Well, it's the angle they marked for us. So it's already marked. Okay, this problem's really cool. So I think the easiest way to do it, and maybe there's another way, but the easiest way I can think of off the top of my head is I'm actually going to draw another parallel line here. Okay. Why am I doing that? What made me think to even try to go about doing that? Well, they give us this 49 degrees, and I don't think it's a red herring. I don't think it's there just to kind of be extraneous information. So I'm kind of looking at how to incorporate that in order to get to the answer. And the only way I can kind of think to do it is to either make this into a right triangle, and we can look at that in a second, or to just draw a parallel line here. And if we draw a parallel line here, well, we know that two parallel lines, opposite interiors. So if this is 49, this is going to be 49. Well, if this is 49 degrees, then we're looking at 137 minus 49 to get this angle that I'm going to put in yellow, right? This angle here in yellow. So this angle in yellow is going to be 88 degrees. Okay. So here's where it gets really cool. And let's think about it this way. If I draw, I'm going to draw these kind of at a slant. I draw this angle and this angle, and then I draw a transversal. Okay. If this is, let's say, 120, then we know this is 120, and we know these two are 60. Well, going back to this diagram right here, if this is 88, if I extend this line, and these are parallel, this green and DE, right? These are parallel. So if this is 88, then, right, if this is 60, this is 60. If this is 88, this is 88. And this is a straight line, so that means the question mark has to be 92, the angle we're trying to solve for. Real quickly, if you can end the video here if you prefer. I'm just going to look at this problem one other way just to see where it leads. We'll see real fast if we get anywhere with this. But if we were to go like this, call this a right angle, okay? So we have 90 and 49, so that's 139. So when we add them together, right? So if we have 139, that means that this is 41. And knowing that that is 41, does that help us in any way, shape, or form? I don't see it necessarily helping us. Even more problematic, actually, is that I don't know if it should be 41, because if we draw this right here, really this is a straight line. So if this is 137, this should really be 43. So with the straight line, we're not necessarily drawing 90 degrees. Yeah, this kind of becomes a circuitous thing. We're not going to get anywhere with this triangle. It just doesn't add any information we don't have. I mean, if this is 49 and this is 43, add those together and we're going to get 92. Oh, maybe this will help us actually. Okay, this could help us. So instead of maybe thinking outside the box and dropping the parallel line that I did, if this is 92 degrees, then following the logic we had earlier, if BA is parallel to DE, this is going to be 92 degrees, and this is going to be 88 degrees, so this will be 88 as well. So yep, that is another way to get it. Sorry that I said it wouldn't get you anywhere. I didn't see it originally. Okay. Anyway, good luck with this worksheet. It's only 16 problems, so it should be a pretty quick one to get through. I think this video definitely went over 15 minutes, so I lied at the beginning. I didn't keep my promise, but hopefully you found it helpful.